Stream starting. Just go like that. Okay. This is OBS. And right. Okay. Right there. And nothing. All right. Okay. This one. Stop. Print. And just test the sound, right? And you have to open the mouse. Turn on right now and you see it. Great. Close is okay. And the headphone, right? This one too. Okay. Open. Okay. Test sound 1 2 3 ตัว test 1 2 3ครับtest 1 2 3 all right. So good morning everybody, welcome you to SCI 33206, which is physics number 4, right? And somebody else saying, okay, everybody has already written your name there, and I'm not sure whether the sound is good or not.เสียงไปไหมครับเสียงแต่ผมไม่ได้ยินนะครับตรงนี้เดี๋ยวเซตผมฟังก่อนนะครับว่ามันมาถูกช่องหรือเปล่าoutstanding. Okay. Okay. 1 2 3 1 2 3ครับthe one is using that one. Okay. Now let's share the screen, right? Time starting, and we will continue our lecture in the 5th chapter, right? Solid liquid, right here for the M604, right? I hope the picture. Yes. The picture goes well. And yes, we would continue our theory in Pascal Law, right? We I think for M604 we arrive at this one, right? SCI. Okay. you have hydraulic lift right here. Okay, it's a lift that is used for car, right? For automotive application. You can find this hydraulic lift in several garage, for example, in Be Quick, in several Thai station, okay, because they're gonna need to lift your car up, and yeah, it's quite useful once you know everything or the theory of the theory of Pascal Law, right? The Pascal Law talks about how you could determine the pressure and also related to the force too, right? Because it's force is only the product of pressure to the area, right? Yes, force is the pressure times the area. Fluid is on the left cylinder, showing their relative height. Okay, and there is a slight difference. Let's close this one, and we share another good note, right? For M60. Okay, this M605 for us is right here. Okay, the car lifting is left on this panel, and this panel is connected to the bigger piston, right? The bigger piston will go up, right? Because we leave the force here again. This force is gonna push this piston down, and because the fluid try to escape, right? And there will be pressure everywhere, and one of the pressure is the one that try to move this piston up, right? Because they cannot go somewhere else, okay? Because this is the closed system. All right. Yes. There is a slight difference in the pressure at the input. Okay, this one, and the output. This is the output, and because you know that there is a different level here, level difference right here. This one, when this fluid is higher than this level, it means we should have also an additional pressure, okay, due to this amount. But for us in high school or in secondary school, it is simpler to neglect the small pressure difference right here, okay? And now we consider the first example in a car lift, right? Used in a service station. Compressed air exerted on a force, exerts a force on a small piston. Okay, they use the air pump. Okay, the device that can compress anything by using the air. All right, and a small piston of a circular cross section having a radius of R1 5 centimeter, okay, which is quite small. All right, you have the piston right here. You have the whole car lift like that. Okay, this side contains a small piston, right? and this one contains a bigger piston in it's gonna move up, right? And this pressure is transmitted by an incompressible liquid. Okay, this term is quite important. Incompressible, which means that we can apply the Pascal law, which state that F1 by A1 equals F2 by A2. Okay, because the pressure are different. เดี๋ยวนะครับมีคนพิมพ์อะไรมาหรือเปล่าชื่อโอเคจานรับหน่อยครับโอ้ sorry ดีนะที่ผมใส่หูฟังโอเคโอเคครับปอนะปอนี่คือประภาวิทย์นะเท่าที่ผมจำได้ครับโอเคwho else wanna join the Zoom classroom just let me know, okay? Because it's in another monitor. I cannot see it. And let's move to that. Okay. You have this set up, right? In the pressure. Yeah, this word is quite important. Incompressible liquid. Okay, it means we can apply the Pascal law. Our second piston, which is the bigger one, this one has the radius R1 5 centimeter, right? 5 centimeter, and this one here has the radius of 15 centimeter. Wait, yes, 15 centimeter R2, right? R2 15 centimeter, and neglect the weight of the piston. Okay, assume that the piston here are very light. Okay, and the force must be the compressed air exert on the small piston. So what is the value of this force, right? And in order to lift a car weighing 13,300 Newton, and what air pressure would produce a force? Okay, that's the first question, right? In order to lift a car weighing 13,000, so it means 13 ton, okay, approximately. Okay, we have a holder like this, okay, and we leave a truck. I think this would be a truck actually, because it's 13 ton. Okay, usually one car would be only 1 ton, right? So this is a truck, okay, and this one is no, it's not kilogram, it's weight already, so it's around 1 car, single car. Okay, and the force here, the weight, right? The weight here, the weight is 13,300 Newton. All right, and what air pressure? Okay, so we need to know the compressing force right here. Okay, F1, right? I think. What is the value of F1? That's the first question here. Okay, F1. What is that? มีใครไหมครับผมพยายามชำเลืองดูจอเรื่อยๆนะครับขออภัยด้วยนะครับปอนะครับ The second question, what air pressure will produce a force of that magnitude, right? So you know that this is the piston, right? And here is the liquid. Okay, you have the liquid inside. This is called incompressible liquid. Okay, incompressible liquid. This is the liquid. Okay, you fill it with the liquid, and you try to okay, this is the closed section. Okay, you close this one. Okay, and you you drill it. Okay, you drill a hole here. You let the air get into this. Okay, you let the air get into this small hole, tiny hole, and you try to compress this piston by air. Okay, and of course there will be pressure caused by the air, and that pressure will take place in terms of force, right? Because once we multiply the pressure by the cross-sectional area, we get a force, and this force F1 will compress this liquid, and this one is gonna move up. It can lift this truck or this car up, right? That's the whole system, the whole mechanism. All right, I hope you will understand the configuration of this problem. It's quite complex, right? It's quite it's an extension to the typical problem for us. Okay, and let me observe what's going on with you in the YouTube channel, right? So that I can see who has typed something in the YouTube channel. Okay, the whole system is like that. And มีคนพิมพ์อะไรมาสักอย่างเดี๋ยวดูที่ไลน์ก่อนนะครับnothing นัทพัฒน์อิชิโกสินครับอ๋อคุณดูที่อันนั้นใช่ไหมครับอ๋อโอเค yes okay no problem up to you okay yes นัทพัฒน์yeah we have let me monitor what's going on with you in some channel, because I need to capture your name right from the right Natapat. Okay, I can see you in most people are in the Zoom to YouTube channel, right? 6th lecture right here, and right, okay, and I'm gonna reduce this page, right, so that I can see you this one for most people in Zoom to YouTube channel โอเคณัฐพัฒน์อยู่ที่อันที่มันถ่ายตรงหน้า iPad เลยนะครับokay, all right. But the problem is that I cannot see. Okay, right now no problem. And yes, let's go ahead with this problem. We need to calculate first the F1. Let's try to completely understand what is going on. The air pressure will produce a force of that magnitude. Okay, the second question is P air. Okay, P air, what should it be? And show that the work done by input and output piston is the same. Okay, and the third scenario, the third question is proof or verify, right? Verify work input equal to work output. Okay, out. Okay, let's start with the first one. F1, right? F1 is the force on the left hand side on the smaller piston, and of course we have this equation, right? The Pascal law. The Pascal law is quite easy. Okay, pressure at this location and this location are the same, right? We neglect the effect of height difference. Okay, the when this one is higher than this one, we neglect the pressure caused by the small amount of liquid above this level. And yes, what we want to know is F1, right? From the Pascal law, we have F1 by A1 equals F2 by A2, right? So let's manipulate this equation. You know that F1 is gonna be F2 A1, right, divided by A2. All right, you may have to substitute everything, right? F2, what is that? F2 is the weight of the car, right? We neglect the piston and the supporter mass here. Assume that they are very light, and F2 is the 300 Newton. All right, that's the first quantity you need to know. A2, A1, what is that? A1, because the piston has the cross-sectional area as a circle, right? So we would what happened? ทำไมมันมาเป็นแบบนี้นะครับ this one. All right, and because this one has the circle, so we need to use the area of circle, right? And pi pi r1 square, right? Pi r1 square, and you know that r1 is 5 centimeter, right? And and yes, you have here pi 5 times 10 raised to negative 2 and square, right? And A2 is pi r2 square, right? And it's gonna be pi and 15 times 10 raised to negative 2 square, right? So we leave all these three quantities into this expression, and yes, F1 will appear as F2, which is 13300, and times pi A1 is 5 times 10 to negative 2 and square, right? And you have the denominator here 15 times 10 raised to negative 2 and square, right? Yes, we still leave 13300 like that, and yes, you know, pi and pi can cancel each other, right, easily right here. And inside this we have inside the square we have 5 and 15, right? And times 10 raised to negative 2 times 10 raised to negative 2 and square, right? 10 to the negative 2, and you know that we can easily again cancel the unit conversion term, right? And 5 and 15 is gonna be number 1 and number 3 easily, and we have finally 13300 by 9, right? And yes, you can go to AD calculator, right? It's right here. I don't know. Yes. 13 133 300, right? And divided by 9, it's 1477, right? 14, it's approximately 147.77, right? And so on, right? With the number 7 infinitely. Okay, and the unit F of F is, of course, is Newton, right? We get the first question, the answer for the first question, right? Let me capture what you type here a little bit. Okay. Okay. เผาบินเนาะแล้วก็ until กันทพล right? And from กันทพล to อัครวัตร all right, and one person here ณัฐพัฒน์อิทธิโกศลนะครับ yes okay the desktop this one อ้าวทำไมมีเท่านี้กี้ผมก็แคปเจอร์ไปเยอะนะปวินคนแรกมานี่ครับ and from กันทพล toณัฐพัฒน์ right เดี๋ยวครับงงครับว่าทำไมแคปเจอร์แล้วไม่ไปไม่มาเฉยเลยครับ I don't understand คือคอมพิวเตอร์ผมรันงานวิจัยไปด้วยนะครับ CPU น่าจะนะครับโอเค no problem okay the second question is right here, right? What is the air pressure? Let's check whether our solution is correct or not. It's F1 is right there. It's 1,000, right? I'm sorry for that. ไม่มีใครท้วงผมเลยหารมันต้องเหลือพันสิ Okay, it's one. What is that? 1477. What is that? Here, right? 1477, right? And 7 infinitely. Yes, and yeah, that's correct. And the next one is we're gonna need the term P air, right? P air or P2 is given by the the force F1, right? Divided by the cross-sectional area of the piston on the left side here. Okay, this one. All right, and P air or pressure will be will of course be 1477.77 7 divided by pi r, which is 5 centimeter, right? And 10 to negative 2 square, right? And let's see what is the result in decimal unit, right? 1477 like that. And let's see what's going on right here. This is the force F1 and divided by pi, right? Pi times 5e minus 2 and square, right? นึกไม่ออกว่าถูกใช้ Google เราเนี่ยครับง่ายๆนะครับโอเคไหมก็ so you get the result right? That's 59892.077 59892.077 blah blah blah, right? And let's check whether it's incorrect. My God, 1478, right? It's approximately less than 5. What is the reason why we have that? Moment สูตรลับประวีนด้วยคอมพิวเตอร์ช้านะครับไม่ใช่เจ๊งนะครับเนื่องจากว่าประมวลผลหลายอย่างครับตอนนี้ผมน่าจะต้องซื้อ Mac mini มาเพิ่มแล้วครับเพราะว่างานเยอะนะkind of okay and Suankularb there in another channel, right? แต่ว่าอันนั้นมันจะกระตุกหน่อยนะครับเพราะว่าคอมพิวเตอร์รันอยู่นะครับขออภัยSuankularbย้ายมาที่อีกช่องแล้วกันนะครับถ้าจะดูนะครับ what else มีคนส่งอะไรมาหรือเปล่าได้ยินเสียงตึ๊ดๆนะ okay alright anything because I send okay to you alright I don't understand why it's incorrect right here one thing that is not clear to me is there should be no okay this term should not exist อันนี้ผิดนะครับต้องไม่มี10 ยกกำลังลบ 3 10 กำลัง 3ตรงนั้นนะมันพิมพ์เกินครับตรงนั้น and okay let's compute it by using okay this one Madonna and right okay it's 133 right? And this is the F1, right? F1 is like that and divided by 9, right? And P air, right? P air is gonna be F1, right? F1 divided by the area of P1 piston 1, right? Which is pi times r square, right? Which is 5 e minus 2. Okay, 10 to negative 2. And square, and we have here A1, 2, right? It's A1, right? Yeah, let's see what is the value of P air. P air is 18816. Okay, which is incorrect, right? No. กด ในนั้นผิดนะครับที่ Google นะครับใช้ calculator จริงๆดีกว่านะครับชัวร์กว่านะครับโอเคone เท่าไหร่นะจำไม่ได้นะครับถ้าเปิดอีกจอจะดี18816 one โอ้8816 right 1.8816 times 10 less to negative to 5 right and pressure is in Pascal right it's Pascal and verify that W input and W output right this is not easy okay W in and W out right so yes the way to do is like this if you want to verify oh my god ผิดหน้าด้วย okay if you want to verify you can start from of course you know that if you move this one right it's gonna stay downward right and this one go up and the liquid will fill from one side to another side and the additional liquid in terms of volume from the right side is going to be A2 times V2 right and this A1 times V1 right but the volume of those sides of both sides should be the same right because we assume that the liquid cannot escape from this closed system so V1 right is gonna be V2 right V left and V right and you know that V1 is delta X right we assume that this piston go a little bit down and that's a small distance according to the movement is noted by delta X right and actually it should be delta Y because it's in the y-axis okay I should not use the delta X it should be delta Y okay delta Y and delta Y1 too right because this is delta and here it cannot go up like delta Y1 because this one has larger cross-sectional area it should go up by the amount of delta Y2 okay delta Y2 okay we want the liquid that is lost okay someone has push it and this one is gonna stay on the right side it's reduced by A which is A1 right times the difference in the height okay it's delta Y1 right and V2 on the right side will be A2 right times delta Y2 and yeah you just substitute this one to this relation right we assume that there is no fluid leak at all in that closed system so you would have A1 times delta Y1 equals A2 delta Y2 okay and you would get the relation like this okay in the opposite way A1 divided by A2 equals delta Y2 divided by delta Y1 right okay and that's the first relation we keep that okay and after that you know from the Pascal law that the Pascal law says The Pascal law said that the pressure inside at the same height, right? Inside this pump, inside this hydraulic lift would be the same at the same height. Okay, so pressure 1 and pressure 2 at the same height. P1 equal P2 could be written as F1 by A1 equals F2 by A2, right? And we're gonna open another page. We keep also this. This is the first equation. This is the second equation. And let's talk about the work, right? The work done by the work on the left hand side and the right hand side. The piston here is gonna move to this one, right? And stupid. Okay. All right. Okay, it moves to the second position, and yeah, this is delta y1, right? Delta y1 right here, and you know that w1 on the left side, w1 on the left side will be f, right? There is f1, right? It should be f1 times the distance that the force exerts on, right? Which is right here, delta 1, right? This factor is the h, right? The distance, so it's delta y1, right? On the right side, we have also the piston, right? In yeah, something like that. And once the time's gone, right? It's gonna move up a little bit like that. Okay, it's gonna move up like that. And here is delta y, delta y2, right? With this distance, and yeah, you would be able to see that W2 is yeah, there will be pressure, and here is F2, right? It just lift this piston up, and it's gonna be F2 times the distance along this force exerting onto that object, right? It's delta y2, and yeah, you can see that now they want to ask us about proof that W equal y2 or not, right? Okay, or not, right? We need to have the question mark up on the equality sign. รับอาหารไหมโอ้ Okay, yes, W1, we need to observe whether this equality holds true or not, right? In order to do that, it means if this one is correct, we're gonna see whether W1 by W2 is equal to number 1 or not, right? I hope you would easily understand, right? This one, you just move W2 to the left hand. We will see whether the ratio W1 by W2 is correct or not, right? Is equal to 1 or not, right? And yeah, let's go ahead with that. Now we start to make the ratio, right? Divide this equation by this one, right? If both are equal to each other, W1 is gonna be W2. And F1, the delta y1, right? Divided by F2 delta y2, right? Now let's go further down. And you know from the first equation that delta y2 and delta y1 has the ratio like this, right? It's a1 by a2, right? So in the opposite way, right? What is the value of delta y1? Delta y1 from this equation, from this the equation number 1. It means that oh no, stupid, this one. ขออภัยครับอันนี้ไม่ถูกนะยังไม่ถูกไม่ใช่ไม่ถูกครับมันยังไม่สุดครับโอเค we have to express it in another form which is f1 by f2 equals a1 by a2, right? That's the second equation. Okay, let's consider the first equation. First equation say that delta y1 by delta y2, okay, delta y1 by delta y2 equals a2 by a1, right? Okay, that's equation number 3. No, this is number 3, right? And here is 4, right? Equation number 4. And in equation number 2, they say that f1 by f2 is a1 by a2, right? So substitute 2 and 4 into equation number 3. So ผมต้องกี่โมงเนี่ย8:30ต้องจะไปได้9:50ป่ะ9:50เนาะ Okay, so yes, equation number 2 say f1 by f2 is a1 by a2, right? So from these from equation number 3 we have w1 by w2 equals f1 by f2 is a1 by a2, right? And from this relational delta y1 by delta y2 is this one, right? It's from equation number 4. It's a2 by a1, right? So yeah, you can say that we don't need to we don't have to go into the detail of those a, right? You can see easily a2 up, a2 down, a1 up, a1 down. Okay, all of these can cancel each other and you get w1 by w2 equals number 1, right? And therefore we can conclude that w1 work while on the left hand side is going to be the work on the right hand side, because this is the closed system. There is no leak of energy at all. Okay, all right, we finish the first example about Pascal Law. And นี่ผมจะลบหน้านี้ยังไงครับจะลบไง Okay, yes, thank you แม่ใช้ไม่เป็นตั้งนานครับsorry ขอโทษครับมีฮัลโหลครับเรื่องอะไรครับอ๋อเดี๋ยวสักครู่ตอนบ่ายๆได้ไหมครับผมติดธุระอยู่ครับครับ sorry ขอบคุณครับสวัสดีครับ all right, what else? Yes, this problem is a good one. Okay, they have 3 sub questions, and yes, let me look at that. Okay, and the last one is quite hard, right? Because it talks about the proof, right? You have to know where the you have to incorporate, right? You have to include the knowledge about the work too, right? Into that, in order to solve that question. Okay, that. Yes. All right. Yeah. Let's go ahead with the next problem, right? The previous problem is taken from the book number 1, right here. Okay, you can see it's taken from book number 1, and the second problem is taken from the book number 2. Okay, in let's say suppose the hydraulic lift shown in figure 45. Let's go to figure 45. This one, right? Figure 45 right here. Okay, and has a small cylindrical piston with radius 5 centimeter. Okay, again 5 centimeter on the left hand side, and a larger piston with radius 20 centimeter. Okay, the bigger one. Okay, the previous problem has the larger piston by 15 centimeter, right? But this one is 20 centimeter, and the mass of the car places on the larger piston platform. Okay, the supporter is 1,000 kilogram, right? It's on the same order. That one is 13 Newton. This one is 10,000 Newton, right? Or you can say 9.8. Even once you use the G as 9.8. Okay. The two pistons are the same height. Okay, the same height as in this figure. What force must be applied to the small piston to lift the car? Okay, what is F1? Okay, on the left hand side, what is that? And how far must the small piston move down? Okay, to lift the car through the height of 0.1 meter. So what is delta y1? Okay, so that we have delta y2 as 0.1 meter. Okay, that's the question. Those are two questions in this problem, right? So let's open the next page, and we are gonna solve this, right? The first quantity is not difficult, right? Because we just apply the Pascal law, right? Once they say they are at the same height, right? The same level. So F1 by A1 equals F2 by A2. All right. Yes. You can see that this is the result, right? And สำหรับตรงนั้นนะผมดับไฟนิดนึงนะเดี๋ยวมันสะท้อนนะครับ All right. Yes. We apply the Pascal law, right? I think this problem is lighter. It's easier than the previous one, right? The former one. And yes, F1 by A1, right? And we're gonna want to find F1, right? So we manipulate this equality in terms of F1, right? F1 is gonna be F2, right? F2 times A1 by A2, right? And yeah, it's not difficult. And we know that R1 is 5 centimeter, and R2 is 20 centimeter. All right. Yes, and let's substitute it into that. And F1 will be F2, right? F2, what is that? F2 is the mass of the car, right? Mass of the car times gravitational acceleration on Earth. And you know that this is 1 ton, right? 1,000 kilogram, right? And you have to multiply it by 9.8, right? Acceleration on Earth, you get 9,800 Newton, right? And let's substitute all these three amounts into this expression. F1 is our target, and F2 is 9,800 Newton, and A pi R1, right? R1 is 5 times 10 raised to negative 2 square, right? Divided by pi and 20 times 10 raised to negative 2 and square, right? And yes, you can see that pi can cancel pi, right? And if you go further, it's going to be 9,800, right, times this ratio, which is 5 times 10 raised to negative 2 and 20 times 10 raised to negative 2. Okay, this is number 5. And here is square, right? And you can see that 10 unit scale quantity, unit conversion quantity could cancel each other, right? And yes, the next one is 5 and 20, right? This is number 1, this here is number 4. And this one you can use your hand, right? It's 4, 2, right? And 4, right? And 5, right? And 0, right? So it's gonna be 2,450 Newton. Let's check whether it's correct or not. Let's check whether. Oh my God, what happened? Sorry for that. I forget to take the square right here. Oh, I'm stupid. So it's gonna be this one, right? 0 by 16. 4, right? 4 and 4 and 4, right? And 4 here, number 2. Number 4, right? And number 4. 5, 0, right? And again 4, yes, and 4, 1, right? And 2.5, right? It's gonna be something like that. It's 612.5, right? It's correct on the left side. Okay, now it's correct right now. Because I was wrong with without taking the square. And how far must the piston move down, right? The next one is the delta y2. Where is that? What is that, right? Delta y2. Delta y2, what is that? ใครพิมพ์อะไรมาแพรินเพรันครับเพรันส่งรูปมาว่าเพรันคือณัฐพัฒน์ป่ะสุรปวินโอเคสุรปวินไม่มีปัญหาครับ up to you yes ว่าผมพิมพ์ไปผิดวิดีโอครับโอ้ไม่เป็นไรครับอันไหนก็ได้ครับ no problem สุรปวิน it's no problem at all อันไหนก็ใช้ได้หมดนะครับไม่ซีเรียสครับผมเปิดให้คุณดูทั้งหมดเท่าที่คุณอยากดูนะครับโอเค now let's go ahead with our next target right yeah but from the previous question we know that v1 is a1 right times delta y1 right and v2 equals a2 delta y2 right that's the cross-sectional area okay if you move it like this okay delta x1 and there's the x2 right if you move it from you move the piston on the left side it's gonna go down right and you have delta x okay the final location minus the first location right the initial location okay and yeah delta y1 and on the right side you start from this level and the piston just go up right and delta y2 is what they request here which is the 0.1 meter right yeah delta y2 is 0.1 meter and assume that this system is perfect right there is no leak of hydraulic oil at all okay there is no leak they have a good seal between the piston and the cylinder and the wall here okay on both sides when there is no leak of hydraulic oil it means that v1 will be equal to v2 okay and with this assumption we would get a1 delta y1 equals a2 delta y2 right and you move what we want to know is we would like to know delta y1 right we move a1 to the right hand side okay delta y1 will be equal to a2 by a1 right and delta y2 on the right side okay and yeah of course let's get into the detail a2 is pi 2 square right and a1 is pi r1 square right and times delta y2 right in yes of course you can cancel the pi and you get delta y2 in front of that and here is going to be the ratio r2 divided by r1 square right so let's substitute delta y2 is 0.1 meter right that's what they want to know and r2 is the bigger radius they say 20 centimeter okay 20 10 to negative 2 divided by the radius on the left side which is the smaller radius and 5 centimeter 10 to negative 2 right and square for that and yeah you can see that delta y1 which is the lower distance okay the distance along this the lower direction we should move the piston right to get that 0.1 increasing height for the car and นะเขาก็ยกรถประมาณ10 เซนติเมตรอะไรประมาณนี้เนาะโอเคso it's 0.1 right and here is 4 square right oh no yeah 5 and 25 4 right so it's 16 times 0.1 is going to be 1.6 meter right of course when you work with a smaller piston you have to reduce more height right so that you can get 0.1 increasing height okay on the right side Okay, I hope it's correct. I hope it's correct. Let's check whether 1.6 meter, right? Now let's move to the next topic, okay, which is buoyant force. Okay, buoyant force. I think yes. According to legend, King Hieron asked this person, Archimedes. Okay, he was he served for the king. Okay, and in Greek, okay, in the ancient Greek generation, and because the king hired him to work in the palace, and he asked Archimedes, this person, to determine whether, okay, in that generation they don't have so many electronic device. Okay, they don't have iPhone, they don't have computer, they don't have electronic stuff at all. So the main duty the people in that generation do is solely to consider something precious like diamond, crown, gold, and something like that. Okay, or silver, or something like that. Okay, for decoration. And one of the king costume. Okay, the thing that the king needs to use every day once he go to the to work, right? Is the king's crown, and he got the crown from a city or some neighboring area, and people have done the crown and given this crown to him, and he was surprised seeing at that time whether his crown is the true one or not, because they said this is the gold crown. So he asked this guy Archimedes to please verify whether this girl is correct or not, is genuine or not, or it's made of other stuff which is called a gold alloy or not. Okay, so the king has no knowledge to tell himself. So he asked this person. He acts as a mathematician or physicist or something like that at that time. And Archimedes, was also surprising, and he was under the pressure. But anyway, he returned from the palace to his house, and he often think about that question. Okay, and he kept that question from the king. Okay, he kept the king's question all the time in his head, and he returns to his home, and at the evening he tried to take a shower, to bath, and there is this piece, right, bathing hub and so on. He leave his clothes out, right? He take his clothes out, and he slowly lay his body down onto the water inside the bathtub, and he found that why he feel that his body is not so heavy as in the air, right? And he feels like he lose his weight when once he try to lower his body down into the water. So this is the main idea how the buoyant force come into physics. Okay, due to this person. Okay, you are unlucky that Archimedes exists in the world. Okay, he should not happens in the world. Okay, he should not exist in the world. But anyway, he is somehow like the founder of this principle, the buoyant force. Okay, let's get into the detail of the buoyant force Buoyancy is a family phenomenon, okay, in Archimedes' principle, okay. After he can solve this problem for the king, he created his own principle. It's called Archimedes' principle. He said that an object is completely or partially, when the object is completely or partially immersed in fluid, the fluid exerts an upward force on that object, okay. Because of this experience, okay, he feel that he is lighter, his weight is lighter, and he created that rule, and he concludes that the fluid exerts an upward force on the object, and the upward force is equal to the weight of the fluid that is displaced by the object. Did you get confused? Okay, if you fill this bathtub fully, okay, with the water, and if you lay your body down into that, okay, of course, the water will get, will exceed the side here, or this four side, and it's gonna get out of this bathtub, right? Because your body has also the volume. Archimedes said that the force that try to keep your body up, it's called upward force, is the product of the volume of that object, of his body, okay, whether he is partially submerged or fully submerged, the volume of that amount times the mass of the liquid that gets out of this fluid. Okay, you just collect all the water that's out of this bath during your lower your body down onto the bathtub. Okay, collect every piece of water, okay, into a container. Okay, you get the volume of your body that is immersed into the water, and yes, the mass of your the mass of your water can be converted to the force, right, by multiplying with 9.8, and that weight is the force that tries to keep your body up. Okay, that's the principle from Archimedes, and yeah, nothing, right? Yeah, everyone has experienced the Archimedes principle every day, but actually we could not realize that. Okay, for example, if you have ever gone to this scenario, มีใครเคยไปนั่งบอลลูนไหมครับ มีใครเคยนั่งบอลลูนไหม หรือว่าเฮลิคอปเตอร์ก็ได้นะครับ เฮลิคอปเตอร์ วันเด็กอะไรอย่างเงี้ย มีไหม Okay, let's take a look at the air balloon and its diagram, right? Of course, there is a fire ignition here, okay, under the air balloon, and this is the actual figure. And if you see the diagram, you can see that the cold air is outside, right, and warm or the hot air is inside, and hot air or warm air has small density, and cold air outside has more density, okay, large density. So this one is lighter, right? It's a lighter fluid. So okay, of course, if you make the fire ignition, it's gonna make the air warm, and it has smaller density, right? And as you know, any fluid, any object that is heavy, that has more density, would stay lower, right? But this one has lower density. He tried to escape to the large density, to any place that has lower density, right? It's like you pour several fluids into the same glass, right? And the lighter, the better that has the lighter density will stay in the upper level, right? And the liquid that is very dense, okay, it's gonna stay will stay at the lower position, right? Yes. The density plays a crucial role in the Archimedes principle, and the greater the density of the liquid, the less far the object is submerged. Okay, if you have a fluid which is very dense, and if you lay your body down, okay, they are gonna not leave your body be immersed so much, okay. But if you lay your body down into the fluid that is less dense, okay, they don't have enough strong force to protect you. You can't get into that liquid easily and deeper, okay. For example, when you swim in the sea water, it has the density somehow 1030. Okay, it's a little bit denser than more dense than the pure water, right? Your body floats higher than in fresh water, density 1000 kilogram per cubic meter. For example, this figure is taken by someone in internet, and I picked it up because I have never been in the Dead Sea, which is in the border between I don't know, it's Israel and Jordan or something like that, okay. And yeah, it's a kind of seawater, but it's very dense, okay. The concentration of the salt is very high here in this sea, and it has higher density than normal seawater in the ocean and so on. So when this lady lays down here, she will not get submerged, okay. She just float like this, okay, because the density of this liquid is very dense, okay. And I think the time is over, but let's go a little further because we just lose our time during the computer setup, okay. And one thing that uses one device that uses the buoyant force is this one, right? A simple hydrometer, the depth to which the weight scale sinks tells you the density of the fluid. Okay, they use also this principle, the Archimedes principle, to build up the meter, which is called hydrometer. It is a meter that measures density. Okay, and here using the hydrometer to measure the density of battery acid and antifreeze. Okay, if you have ever looked at the battery in your car, okay, even with your father car, they use the Archimedes principle to tell us whether the battery is in a good state or not. Okay, based on the density of that acid fluid. Okay, you know that the inside the battery in the own technology they use the lead and so on, right? Acid of lead, and when we have enough chemical stuff, the density is more dense than the pure water, and it should have more density. And they use that principle to measure the status of or the condition of the battery. Okay, hydrometers are devices for measuring the density of a fluid. Okay, in this example, and now I think I need to let you. Have a break, right? So see you on next Wednesday again here in online manner, and the homework for today is about Pascal Law. Okay, find any problem related to Pascal Law or the problem before that. What is that? On Wednesday, what is the problem that we consider on วันพฤหัสเราเรียนกันเรื่องอะไรนะครับผมลืมไปแล้ว พฤหัสเรียนกันเรื่องอะไรเลย What have we เดี๋ยวนะครับ chapter คนที่เซ็นในคนที่ลงชื่อในในซูมแป๊บหนึ่งครับมีประภาวิทย์กับชัยสิทธิ์ครับชัยสิทธิ์มาก่อนเลยครับโอเคwhat we have considered on Wednesday is the story about pressure depending on fluid pressure. Okay, fluid pressure in terms of fluid depending on the depth, right? This formula 59, I think. Yeah, 59 P is P0 plus rho GH. And the second problem that you can choose as the homework is the Pascal Law that uses this expression here, F1 by A1 and F2 by A2. Okay. See you on Wednesday. Bye bye ครับ สวัสดีครับ That's it. Okay. So it's James. Yes. Use this one. Two. All right. This is the OBS channel. That's simple. Hey, why that's go? Oh. Yes. Yes. Okay. Good morning, everybody. Good morning, M605. Are you there? In it's time 10:10, right? To 11:50 for M605. All right. Only one is watching in the Zoom to YouTube, right? Yeah, Panathon is the first person for M605, and I hope that everybody is fine and you could hear me well. All right. Okay. The yes. The next topic for us in this class will be the first example, right, about Pascal Law, right? I think I have to send you the link, right? โอเคนะครับเดี๋ยวผมส่งลิงก์ให้นะครับสำหรับyes for those who could not find yeah for some people who want to get into the Zoom meeting I would often look at your request. I don't understand how we this is Zoom to meeting, right? And just in this is another one. Right in this one นะครับถ้าใครจะเข้าที่ Zoom นะเดี๋ยวผมลองก็ได้เผื่อว่าคุณมาช้าจากอีกห้องนึงนะครับก็เขาเรียกว่าอะไรเขากำลังทำหนังสืออย่างเป็นทางการกันนะครับว่าคุณจะเรียกว่าอะไรคุณจะให้คุณเรียนออนไลน์ได้โอเคไหมก็ว่ากันไปนะanother one is this all right this one right and I'm gonna send it to you right now. Okay, 3 channels in the YouTube. You can watch whatever you prefer. Okay, if you are in urgent to get access to the Zoom, okay, just simply make a phone call from the line. Okay, it's no problem. I can understand it because it's in urgent case because sometimes when I pay attention to the lecture notes in the good notes on the iPad, okay, I cannot I cannot notice someone would like to enter the Zoom meeting, okay, but for those who are watching the result in the YouTube channel, okay, just simply state it. Okay, if you want to get into Zoom meeting, just let me know by line or by any chat program or make a phone call by line. Okay, let's review the study that we have seen last time. Okay, it's about Pascal Law, right? It's Pascal Law F by A, right? P1 equals P2 and P is, as we know at the beginning, pressure is the force per perpendicular force per divided by the area, right? That the first exerts on. All right. Yes. Let's continue our story. Here you can see F1 is the force on the left hand side and A1 is the cross-sectional area on the left side and F2 is the force upward force on the right side which has a bigger piston or bigger cylinder radius in A2 is the, of course, once we have greater radius, we would have also more area. Okay. ก็วันนี้ก็น่าจะสมูทกว่าวันเมื่อวันพุธนะครับเพราะว่ามันไม่ต้องเซตอะไรอันนี้ผมคุ้นเคยอยู่แล้วนะครับถ้าเสียงชัดไม่ชัดดีไม่ดีอย่างไรโปรดบอกครับโอเคไหมโปรดบอกผมจะได้จัดแจงทำให้คุณให้ดีที่สุดนะครับไม่รู้ฟังกันจริงหรือเปล่านะครับโอเคalright okay โอเค605 until กฤตภพนะครับที่พิมพ์มาที่นั่นนะครับที่ช่องอื่นยังไม่เห็นมีคนพิมพ์มาเท่าไหร่นะมีธนกรกลิ่นธรรมนะครับที่ซูมนะครับพิมพ์มานะของ605นะครับที่อื่นผมก็ไม่เห็นนะนัทพัฒน์นั่นก็604นะครับโอเคokay anyway let's go ahead with that we have the ratio right คนขอเข้านะครับปันณทัศน์ okay we have the ratio f1 by a1 and f2 by a2 because the pressures are equal to each other, right? We neglect the additional amount of fluid, as I said last time, and yes, we neglect the small difference of piston heights, okay, and that different heights would cause also additional pressure, okay, and we arrive at the next example, right? The first example about Pascal Law. Okay, Pascal Law is a problem about fluid pressure actually. Let's get into the เดี๋ยวผมเสียบหูฟังนี้ด้วยนะที่เครื่องนี้ครับก็พิมพ์มาแล้วคือมีกรนะครับอีกคนหนึ่งนะครับแล้วก็ปานทัศน์เข้ามาที่ซูมก็เริ่มพิมพ์มาแล้วนะครับ alright ผมพยายามจะไม่เริ่มเลยนะเพราะว่าเผื่อคนเขามาที่หลังนะครับ alright okay yes in this example they consider okay this example is taken from book number 1 right in a car lift used in a service station compressed air exerts a force on a small piston of a circular cross section having a radius of r1 equal 5 centimeter. Okay, where is the page? Okay. Let's draw the car lift, hydraulic car lift system, right? When you know the principle, you can also build up your own car lift. Okay. The most important thing is the piston. Is the model. Okay, if you know the concept, you can build up your product easily. And it just start from this location, right? Okay. This is the piston, right? These are the pistons, right? This is piston number 1 at the initial state, right? Initial state. And here is also the initial state. Okay, you try to compress มีใครจะเข้าอีกไหมไม่มีเข้านะครับพยายามดูทุกสิ่งทุกอย่างนะครับทั้งไลน์ทั้งอะไรนะครับอันนี้มันห้องผมเซตอุปกรณ์เห็นทุกอย่างนะครับดังนั้นค่อนข้างมั่นใจนะครับไม่เหมือนไปที่โรงเรียนแล้วโอ้โหมันไม่ค่อยมันไม่ใช่มันเป็นไม่อยู่อุปกรณ์ไม่ค่อยครบนะครับทำให้บางทีก็ลืมเซตอันนู้นอันนี้นะครับถ้าตรงนี้เต็มมั่นใจนี่มันจะออกทุกช่องได้สบายๆนะครับokay that's the initial state and you compress it right and you compress it it's gonna be at the second state right it like this okay this one will move downward right and the piston will stay at the lower position like this okay and what is this of course when the fluid has no hole to leak right so the piston is gonna go up a little bit, right? Yeah, it's gonna go up like this. Okay, and this one is the final state. Okay, the second state. This is the final state, right? In physics, once we have two situations, right, the first state and the second state, we would say something like that. Final minus the initial one, right? Okay. Yeah. The basic information they have provided is that R1 on the left side, this is R1, right? The input is 5 centimeter. All right. And here R2 is bigger one, the bigger one, right? It's 15 centimeter. Okay. The pressure is transmitted by an incompressible liquid. Okay, let's take a look at this word. It's incompressible mean this liquid cannot change its volume. Okay, let's say we have this liquid, right? It's hydraulic oil. Okay, hydraulic oil is incompressible. Okay, it's incompressible liquid. Incompressible mean incompressible means it's equal to volume doesn't change. Okay, doesn't change, doesn't vary with time, with any pressure. Okay, and it means that from this assumption, it means the Pascal law holds. Okay, Pascal law holds. Okay, we can use Pascal in this situation. Okay. All right. Let's open the next page. And this one, right? Yes. I hope everything would work perfectly, right? All right. Yeah. The first question they want to know here. Okay. What force must be compressed air exerted on the small piston? Oh, I forgot to mention that they close this section too, right? They close this section. Okay. This one is fixed, closed, and they drill the hole. They drill a hole here. Okay. And there is pump. Okay. This is air pump. Okay. This device just again take the air from environment. Okay. From the surrounding area. Take the air and pump the air into this closest space. Okay. Okay, that is hole, and they pump the air into this space. Okay, and when the air is high, is more and more. Okay, they have more pressure, and the pressure of the air is gonna push down this piston. Okay, this one is fixed. Okay, this one cannot change. Okay, this is the closing lid of the additional section, right? And this one is connected fluid, right? When the air here is pumped more and more, right? We have more pressure, and more pressure caused by the air will lower this piston down, and this piston is gonna repel, okay, compress the fluid from the left side to raise this piston up, okay, to make this piston up, and the fluid is gonna stay in this location. Okay, that's the whole story. And they ask us toมีใครเข้าอยู่ไหมครับผมพยายามเดี๋ยวดูเรื่อยๆนะเพราะว่า604เจอแล้วนะครับคือ กดขอเข้าซูมแล้วผมไม่ได้ให้เขาเข้านะครับต้องพยายามดูเรื่อยๆครับโอเคPascal Law Horns and we okay they want to know what is the force we should have here F1 right on the left side on the smaller side what the first question is what is F1 what is that value and of course we are going to apply the Pascal law right because this law holds true and yes F1 by A1 equals F2 by A2 because P1 and P2 are the same right Pascal law said P1 and P2 are the same both pressures are the same here in both sides okay and we use the typical formula for pressure is force divided by area right it is like this and yes the force by area is something like that and we want to find F1 right so we manipulate this expression to something like this F1 will be equal to F2 and A1 by A2 right something like that and let's get into the detail A1 what is the ratio A1 by A2 A1 is of course the area of the cylinder which has the circle shape right here A1 is pi R1 square right pi R1 square and A2 is pi R2 square right and you could easily observe that pi and pi will cancel each other and you're gonna have R1 divided by R2 square like that right and that's A1 by A2 now let's substitute this ratio into the formula of F1 right yeah we have F1 equal F2 right what is F2 the mass here the second piston is okay assume that we have the support supporting base like that and you leave a car which has the weight of 13,300 right it's a car here and you have a car right like that it's W is 13,300 Newton okay like that in yeah the weight of this car is going down right according to the planet right the gravitational acceleration on Earth yeah F2 is 13,000 right it's 300 Newton right in R1 by R2 because now we have found A1 by A2 is only R1 by R2 square right so we're gonna write down R1 right R1 what is that R1 is the radius on the smaller side right so it's gonna be 5 centimeter okay 5 times 10 raised to negative 2 right and on the right side it's 15 so it's 15 times 10 raised to negative 2 right and the power of 2 right and yeah we would have right here 13,300 and of course we can cancel each other by the unit conversion term right and 5 and 15 is going to be number 1 and 3 and we have 1 by 3 square right here it's equal to finally 13,300 divided by 9 right and it's approximately what is that it's approximately 13,300 divided by 9 right it's equal to 1477. 1477.7 infinitely, and the unit for this is Newton, right? You get the force on the left hand side in the at the smaller piston, right? มีใครไหมครับไม่มีใครพิมพ์แล้วนะ Okay, yeah, let's move to the second sub question. The second sub question says that what pressure would put what air pressure will produce the force that of that magnitude, right? So they want to know what pressure we should have here. The pressure of the air, it is inside the air pump. Okay, second one is what is P air? What is P air then in this case? So yeah, we go ahead with that. Of course, we know from the basic formula of the pressure that P is F by A, right? It's on the left side F1, right? In A12, right? This is P air. Okay. F1 is the force that we have got here. 1477.7 infinitely, and divided by the area. Area is pi r, right, which is 5 centimeter, 10 raised to negative 2 and square, right? It's gonna be something like that. And yes, let's get into the detail of the calculation to this, and we would have the result like here. And yeah, this is the area, right? Pi 5 centimeters square, and P is F1 by P is F1 by A1, right? So yeah, like that. And we have to calculate it, right? It's 1.8816. Okay, 1.8816 times 10 to times 10. This is to 5. 10 to the 5. Where is that? 18816. Okay, with the power of 5. And the pressure is, of course, Newton per square meter or Pascal, right? It's Pascal. So something like this. Oh, ขอบคุณครับ. And yeah, we open another page so that we could go ahead with the third sub question. They asked us that show that the work done by the input and the output pistons is the same. Okay, the work done by input and output piston is the same. So of course, when you have a force, okay, you have force like here, and it just go down like this. There is a distance, right? It's called, let's say, delta y1, and here you have delta y2. Okay, delta y1 is the distance along the y-axis by the first piston, and this delta y2 is the distance that this piston move, right, along the y-axis. Okay, for the second piston here. Okay, delta y2, and yeah, when we have the force and if we multiply it by the distance, we're gonna have the work, right? That's the basic thing in work in physics, right? We don't say work in the office. Okay, we are talking about the work in the sense of physics, which is the product of force and the distance, right, along that force exerting or exerts on, right? Okay, we have to we have to derive, right? Verify that W1 on the left side equal W2 on the right side. Okay, now how could we do that? Once we see W1 equal W2, it means also that we are talking about the ratio between W1 divided by W2 equals number 1 or not, right? Yeah. Is that correct? Okay. In under the question, okay, we are not sure yet, but let's see whether this ratio is number 1 or not. If this ratio is number 1, it means the work done by the first piston will be the same as the work done by the second piston. All right, it's not. Is it understandable? All right. Okay. Before we go to that proof, you know that the liquid here in this area, okay, the liquid in this area should be the same as the liquid in this area, okay, because we assume that this car hydraulic lift, okay, this hydraulic car lift is has no leak, okay, there is no hole or the seal of the piston. It works very good, works perfectly. It's impossible that the oil will get escape from this closed system. So when the oil is not leaked, cannot be leaked, okay, the volume of the liquid at these two locations would be the same. All right. When the volume are the same, so we would see that volume on the left hand side, the V1 will be equal to V2, right? And if you go to the detail, V1 is A1, right? Oh, A1 times delta Y1, right? Because the volume is the cross-sectional area A1 times delta Y, right? You move it along the y-axis by this amount. So we say that the delta Y1. And for V2, we have also A2 and delta Y2, okay, because you have A2 here, the cross-sectional area of the second piston, and you move it up, right? You're gonna have delta Y, okay, delta Y2, which is right here, okay, delta Y2, okay. Now we could compute the volume at the second side too, right? The bigger piston. And now it's time to substitute this volume into this expression, the volume here also into this expression. We get A1 delta Y1 equal A2, sorry, and delta Y2 here. All right. And let's move something to the same side, right? So we have delta Y1 by delta Y2 equals A2 by A1. Okay, please note that it's in the opposite direction, okay? Number 1 stay at the numerator here, but number 1 on the right side we stay at the denominator, okay? And that's the first equation. Okay, let's keep it. Now we have already that expression, and let's get back to the Pascal formula. here F1 by A1 is equal to F2 by A2. All right. So we have here Pascal Law, right? So we have F1 by A1. F1 by A1 equals F2 by A2, right? So yeah, let's move something together to stay together. Right? We could say that F1 by A1, oh sorry, F2 will be equal to A1 by A2. Okay, and we keep this as the second equation. Okay, now let's get to our destination. We want to see whether W1 and W2 divided by W2 equal 1 or not. Okay, what is W1? W1. Okay, if you take a look at this movement, right? Work is F by A, right? F times A. So F here, F1. And you have also area here, area number 1, right? Sorry. Delta X, delta Y 1, right? Is the distance along the y-axis for this force. So W1 will be the product of force F1 times delta Y1, right? Delta Y1. Okay. And again, the same. W2 will be equal to the product of force F2 raising up, right? So it's the product of the force and the distance along the y-axis, which is delta Y2, right? F2 delta Y2. Okay. And according to our target, we want to see whether W1 divided by W2 is equal to number 1 or not. So let's divide these two equations. We're going to have combine these two equations. We have W1 by W2 will be F1 delta Y1 by F2 delta Y2 all right, and W1 by W2 will be F1 by F2 and times delta Y1 by delta Y2, right? And yes, from the let's keep this equation as equation number 3, and we open another page, right? We open another page. We open another page and as substitute equation number 1 and 2 into equation number 3, right? So we would have W1 divide W2, right? F1 by F2 is A1 by A2. So the first term is A1 by A2. And for the second term, delta Y1 by delta Y2, okay, we have got the relationship somehow right here, okay. here. Okay, delta y1 by delta y2 is a2 by a1. So what is this? Delta y1, yes, delta y1 by delta y2 will be a2 by a1. So this one is a2 by a1. Okay, and you could see that we can cancel each other by this, right? And it's finally only number one. Okay, here is the complete answer to the first problem today. ขออนุญาตลดแอร์นิดนึงนะครับ Yes. Now we go to the next problem to the Pascal law. And what is that? Next problem to the Pascal law is this one, right? Here. Okay. Suppose we have, oh, no. Yeah, this one. Okay. Suppose we have a hydraulic lift as shown in figure 45. Okay, we have hydraulic lift. In figure 45. Okay, and this example is oh, ทำไมหายเลย oh, here. Okay, this example is taken from the book number 2, right? In yeah, you have here the lift electric I don't know, the hydraulic lift. Okay, is taken from book number 1 here. We consider the hydraulic lift from book number 2, which are really exactly the same. Okay, and suppose the hydraulic lift shown in figure 45 has a small cylindrical piston with radius 5 centimeter. Okay, yeah, let's draw this problem. Let's draw this problem, and yeah, on the left side we are gonna leave it as the smaller piston, right? In yes, again, it's gonna move somehow to the upper location. Yes, right here. And yeah, this is the piston number 1, right? Piston number 2, and it's gonna move down. The distance here is delta y1, and it is gonna move up in here. Delta is delta y2, right? And suppose that the small cylinder has radius of 5 centimeter. So radius here is 5 centimeter. And on the right side piston has the radius of 20 centimeter. All right. And the mass, oh, okay, they placed this object to support a car, right? And there is a car which has the wheel here and wheel here. Oh, I'm sorry for that. I cannot draw well the car. And the mass of the car is here M1000 kilogram. Okay, you have 1000 kilogram for the mass of the car here. And let's jump into the first question. Assume that the two pistons stay at the same level and as same as this configuration, right? In piston are at the same height. What force must be applied to the small piston to lift the car? Now we consider the Pascal law, which is F1 โอ้สีจางไปนะครับโอเคF1 by what? A1 will be F2 by A2, right? But you know that we want to find F1, right? So you can move it. F1 will be A1 by A2, right? Times F2. And let's consider the ratio of the cross-sectional area. A1 by A2 is equal to pi R1 square, right? Divided by pi R2 square. And yes, of course, we can cancel the pi together from each other. And we have here R1, R2 square, like that. All right. In นะครับแล้ววิผลนี่จะมาสุดท้ายเสมอครับ Okay. Yeah, we have the ratio of A1 and A2 like that. And now let's substitute this ratio into F1 expression. F1 expression will be A1 by A2 is R1 divided by R2 square times F2, right? And yes, R1 is the radius on the smaller size of the piston, which is 5 centimeter, and the bigger piston has the radius of 20 centimeter, right? So this one here we have 5 centimeter. Centimeter is the multiplication by 10 to the negative 2, and R2 is the radius of the bigger piston, which is 20 times 10. Let's just 2, right, on the same scale, centimeter. And F2 is the base of the car, which is 1000 times the acceleration of the right gravitational acceleration of 9.8 in yeah, you can see that I forget number 2. Okay, in this one you cancel each other. In 5 and 20 will be 1 by 4, right? In yes, it's gonna be 9,800, right? In front of that, and the ratio here is 1 by 4 square, right? Which is 16, right? Okay, F1 will be 9,800 divided by 16. Okay, and let's find the list out, right? No, it's not approximation at all. It's equality. 4, 4. Okay, 4, 2, and 4. What is that? 4, 2, 8, right? In 18, 4, 4, right? In 25, 0, right? And now again 4 here in 24 is going to be 6, 5, 1, 0, 2, 8. Mm-hmm. 1, 2, 0.52, right? So it's going to be 612.5 meter. Oh, no, Newton. I'm sick. Okay, That's the Newton. In second quantity they want to know is the okay, to lift the car we have to exert 612.5 Newton. And how far much the small piston move down to lift the car through a height of 0.1 meter. So what is delta y1? Once we know that delta y2 is 0.1. Oh, not millimeter. Okay, 0.1 millimeter. 0.1 meter. And yeah, we start from the fluid that cannot disappear. Okay, this is the uncompressible fluid, and this fluid didn't escape from this device. So V1 will be equal to V2. Okay, because there's no leak of hydraulic oil at all. Okay, in yes, V1 will be, okay, let's say V1 is A1 times delta Y1, right? V2 2, right? A1 delta Y2, right? And now we have again the ratio, right? They want to know V1, delta Y1. Okay, delta Y1. Okay, we have here A1 delta Y1 equals A2